Lesson 1.2. In this lesson, you will be able to write statements of inequality comparing two fractions or two decimals using the symbols less than or greater than. You will also be reviewing how to convert fractions to decimals and annexing decimals to make the comparison of inequality straightforward. In this lesson, we will be talking vocabulary. The first word is convert, a change in the form of measurement, different units, without a change in the size or amount. And this is important because it does not change the size of the amount, it just changes it to a different unit. And to annex. Annex is when we use for decimals, and it's to add or to attach as an extra, and we will be doing that. All right, let's compare two fractions, 2/3 and 5/6. And in order to put both of those on a number line, they have to have the same denominator. So we need to rewrite the fractions so they both have the same denominator. Well, how do we do that? Well, we need to think back to last year about equivalent fractions. Equivalent fractions have the same value even though they may look different. So we need to find a multiple for 2/3 and 5/6. And how do we do that? Well, we look at the denominators. The denominator 3 and the denominator 6. We need to have a multiple of 3 and 6. Well, we can do that in our head because we know that 6 is a multiple of 3. But what if it was another number that we didn't know in our head? You would have to write out all the multiples. So let's write out the multiples of 3 and 6. We have 3, 6, 9, 12. And let's write out multiples of 6. 6, 12, 18. Well, we want to take the lowest one, 6. Now, also making equivalent fractions, we need to think about how, since 5/6 already has the 6 as a denominator, we will find the equivalent fraction for 2/3. Now, since the denominator 6 is larger, we will use multiplication. We will think about 3 times what will equal 6? Well, 3 times 2 will equal 6. And we know that whatever we multiply with the denominator, we need to multiply with the numerator. So 2 times 2 equals 4. So our new equivalent fraction is 4/6 and 5/6 because that's the two we are comparing. Now that we can do that, we can put both of them on a number line. So let's draw our number line. And since it's in 6, we need to have 6 intervals. 1, 2, 3, 4, 5, 6. And we will label them 1/6, 2/6, 3/6, 4/6, 5/6, and 1 whole, or 6/6. Now we will put 2/3 on the number line. Well, we know that 4/6 is an equivalent, so we can write 2/3 on the top. And we can also, we know that 2/6 is 1/3. So let's mark them. Let's mark 4/6 and 5/6. Now we want to compare the two. We want to see which one is greater. Well, 5/6 lies to this, and we know that anything that increases on the number line is getting larger. So 5/6 is greater than 2/3. All right, remember, reviewing finding equivalent fractions with unlike denominators, you must convert the fractions to an equivalent. And then when you go to compare them, use the original fractions they asked you to compare. Originally, they asked you to compare 2/3 and 5/6. And we know that we found that 4/6 was an equivalent of 2/3. But when we go to compare them to see which one is the greater, we always use the original fraction. 5/6 is greater than 2/3. All right, let's compare two decimals, 1.3 and 1.15. In order for us to do this, place value is the key. Just as making equivalent fractions with the same denominator, when we are comparing decimals, we need to have the same place value. And we see that 1.3 is 3/10 and 1.15 is 15/100. So in order for us to do that, we must annex zeros, which means to add zeros to our decimal so they can be both place values. So let's start with 1.3. This is in the tenths. 1.15. This is hundredths. So in order for us to make 1.3 the same place value, 30/100ths, we must add a 0. Now we can compare the two. We can now place them on the number line. So we have our number line, and we're going to start out with 1, and then we're going to have 1.1, 1.2, and we need to go up to 1.3. 1.3, and we'll do one more, 1.4. Now we see that 1.3, even though we have a 0, we can write it down here, 1.30. We see that it's here on the number line. Well, 1.15, if this is 1.0 and 1.20, then it will be in between the 10 and the 20. So we will place 1.15 on this number line here and mark it. Now we need to find out which one is greater. Well, 1.30 is to the right of 1.15. Now that we have seen that 1.30 is to the right of 1.15, and we know that anything that is to the right is larger, we know that 1.3 is greater than 1.15. And how we would write that is 1.3 is greater than 1.15. Remember, common mistakes. Students may assume that the decimal 1.15, since it has a 15, it is greater than 3 in 1.3. Don't confuse yourself. Remember place value. You're going to hear me say place value with decimals all the time. So make sure that you annex and you add a 0 so both have the same place value, and then you can compare them. And you would know that 1.30, when I annex the 0, is larger than 1.15. Let's look at missing decimals. Let's label the missing decimals on this vertical number line, and then we will compare each pair of decimals using greater than or less than symbols. Here is our number line, and it starts at 0, and then we have 0.01, missing number, 0.04, 0.05, missing number, 0.07, 0.08, missing number, missing number. Now I know that you have already seen this pattern. You're seeing that it's counting by ones, hundredths. So this would be 0, 0.02, 0.03, then we have 4, 5, 0.06, 7, 8, 0.09, and this would be the whole number. 0.09, then we're going to come to 0.1. And then if I wanted to add a 0 afterwards, we would see that would be 10. But it's tenths now. So let's compare. Is 0.1 greater than or less than 0.05? So is 1 greater than or less than 5? Remember vertical number lines? The values go up. So 0.1 is greater than 0.05. The next one. 0.02, is it greater than or less than 0.7? 0.07. Well, 7 is above 2, so 0.02 is less than 0.07. Did you know every whole number, fraction, and decimal can be represented on a number line? Any given point on a number line can be written in different forms. All right, let's talk about converting fractions to decimals. We will convert 1/5 to a decimal. Let's start with a review of how to convert a fraction to a decimal. Step 1, find a number you can multiply the denominator with to change it to 10 or 100. We're going to look at how to change 1/5. We want the denominator to become 10, 5 to become 10. Step 2, multiply both the numerator and the denominator by that number. 1/5, we said we're going to multiply it by 2. Here's our denominator. Here's our numerator. Step 3, to write a fraction as a decimal, we need to take the new numerator, 2, and we need to look at the denominator to see how many zeros we have. We have 1 0. So in our place value, for place value with 1 0, we have a decimal point. Let's not forget to put our 0, our whole decimal point. And we have 1 0, we have tenths. So we're going to place the 2 there. So now we have turned 1/5 into 2 tenths. Let's try some more conversions of fractions to decimals. Let's start out with 2/5. Remember, in step 1, we have to take the denominator and we have to change it to a 10. So we're going to multiply 5 by something so we can get a 10. 5 times 2 will equal 10. So now I'm going to take my numerator and I'm going to multiply that by 2. My new numerator will become 4. Now on step 3, we have to take the numerator. In step 3, we take the numerator, which is 4. In step 3, we take our numerator, which is 4, and we look at our denominator to see what place value it is on how many zeros. It has 1 0, so we know that's the tenths. We'll take and put our 4. So we will place it in the tenths. We'll take 3/4. Well, is there a number I can multiply 4 to equal 10? No. So I will have to go to 100. Remember, we're either going to go to 10 or to 100. Is there a number that 4 can be multiplied by to equal 100? Yes, 25. So 4 times 25, we have now multiplied 3 times 25, and that equals 75. Now, to turn it into a decimal, again, I'm going to take my numerator, look at my denominator with my zeros, and I know it's in the hundredths, so it's 7/5. 3/5. 5 times what will equal 10? We know it's 2. 2 times 3 is 6. 1 decimal place, 6/10. 4 times 5 times 2, 8. So now we have 8/10. Equality. Let's look at what is greater, 1/4 or 0.3. We have our decimal of 3/10. We have a fraction of 1/4. Let's convert our fraction to a decimal. 4 times what will equal 100? From the previous slide, we saw that it was 25. 1 times 25 is 25. Keeping with place value, 2 zeros, so there will be 2 spaces after the decimal. So we have 0.25 and 0.3. We also need to make sure that each one of our decimals both have the same decimal place. Well, this is hundredths, this is 10. And add a 0. Now they both have the same decimal place. Draw my number line, and I see that I have 3 and 2. So I'm going to divide it into 4s. 1, 2, 3, 4. This will be 0.1, 0.2, 0.3, 0.4. 0.25, it's going to be in the middle. So 1/4 5, and this is 3. So which one is greater? .3 is greater than 1/4. Let's review. To compare numbers in different forms, first rewrite the given number into the same form. Then compare as you would 2 fractions or 2 decimals. When writing the statements of inequality, use the original decimal or fraction to show the inequality. In this lesson, you can now represent various fractions and decimals on a number line. You can interpret and write statements of inequality for 2 given positive numbers using the symbols less than or greater than. Don't forget to fill out your whisk. See you tomorrow. Thank you for watching the Flipped Classroom.